Okay, this is Year 8 revision on Pythagoras' theorem, and we're starting from question 17 of the revision sheet. In this question, we're asked to find the length of the path going through the park. So this would be the park, and this is the path, and we can see that the dimensions of the park are 14 by 11. So we really need to label this side P, and this is a rectangular park, so I'm going to put a right angle there as well. So I've put a P there, and the P is my hypotenuse. So I'm going to put a circle around that as well. So we're going to start off with, we want to find the P, so we should write that out first. Now that's the longest side, so we do P squared, longest side squared equals the two shorter sides squared. So we start off with P squared equals 14 squared plus 11 squared. So we'll write that first line first. Now because 14 squared and 11 squared are on the same side, we can just work them out on our calculator. You can do them individually, or you can do it all in one go and get P squared is 317. Now remember again, P is the square root of 317, and doing that on your calculator, you will get that P is equal to 17.8044. Now remember, we need to round it, so we'll look at the third decimal place. Now we've got 17.80. 0 is the second decimal place, so we need to look at the third decimal place, which is highlighted in yellow. Now that number highlighted in yellow is 4, which is less than 5, so we don't change anything. We don't round that 0 up. We just keep that second decimal place the same as a 0. So we end up with P equals 17.80. Now for question 18. So we've got a baseball field and it's shaped like a square, so that means we've got right angles here in all the corners, and the side length of the square is 27. So if this is 27, and so therefore that length is also 27, so we need to write 27 on your page there. And we're asked for the distance between home plate and second base, so we need that distance there. So we're going to need to label this diagram and put a D here for distance, and we're going to have to put a 27 over there. So I've just put my D there for this distance. We've got 27 over here. So we can see that we've got a right angle triangle with the right angle there. Remember, the longest side is opposite the right angle, so D is the longest side, and that's the side that we want to find. So we go longest side squared equals two shorter sides squared. So we write D squared equals 27 squared plus 27 squared. So I'll just write that out there. Now we can just work out 27 squared plus 27 squared on our calculator. And you get 729 plus 729, which is 1,458. Now you can just do that in one step if you want. Now remember, the next step is to work out what D is, because we've got D squared, so D will be the square root of 1,458. You work that out on your calculator, you get 38.1837. Again, if you look at all the answers, they're all to two decimal places. So to work out this second decimal place, we need to look at the third decimal place, which is only a 3. Now that 3 is less than 5, so no rounding up happens, so it stays as 38.18. So that's what D is, 38.18. Now, to go to the next question. Okay, now for question 19. Now in question 19, we're asked to find this length B. Now, remember, this is Pythagoras' theorem we're working with, so we need to work with a right angle triangle. Now we do have a right angle triangle here, but we only seem to want to find this side. We don't seem to know the other side lengths. But look, we've got a rectangle up here, and the length of this side is 5, and the length of this side is 2.4, but the length of this whole side all the way down to the bottom, so from the top to the bottom, all of that is 6. Now if just from on this side, from the top to that bottom there is 5, that means from there to there is 5, but if the whole thing is 6, this extra little bit must be 1. So I'm just going to put that there on my diagram, that this little bit is 1. But what I'm actually going to do, I'm going to draw this triangle down here next to that other triangle, and we just said that that little extra bit there is 1 because this bit up here is 5. So we've got this triangle here and we've just got one length on it. We know that this bit here is 1. We know that the hypotenuse here is b. To be able to use Pythagoras' theorem, I really need to know this other side here, which is the same as this dotted line there. If it's a rectangle, if that's 2.4 up there, then this dotted line down here is also 2.4. So I'm going to write that on my diagram. So now I seem to have enough information to be able to start my question. So again, the hypotenuse is the b, so I'm just going to put a circle around it. So b is my hypotenuse, I'm just going to put a circle around it. Okay, so we can say b squared equals 2.4 squared plus 1 squared, because longest side squared is the 2 shorter sides squared and added together. So I'll just start with that. So we've got b squared equals 2.4 squared plus 1 squared. You can just work that out on your calculator, and this time I've actually just worked it out all in one go. So 2.4 squared plus 1 squared, I got 6.76. The next step, b is the square root of 6.76, and you get exactly 2.6 centimeters. So our answer will be C. Okay, so don't forget, if you've got a diagram like this, you need to work out the missing sides in this right angle triangle. So draw a separate triangle first and fill in those missing 2 sides. Okay, and then remember again to circle your hypotenuse and then write Pythagoras' theorem and then just continue from there. Okay, we're now looking at question 20. Now the questions are starting to get a little bit trickier now. And the first question is to test whether a 30 centimeter ruler can fit into a rectangular pencil case of dimensions 26 centimeters by 18 centimeters. Now obviously the 30 centimeter ruler cannot sit flat down the bottom. So if I just bring in a 30 centimeter ruler, I mean it's not really 30 centimeters, but I'll just bring a ruler in and pretend it's 30 centimeters, okay? Well, it's obviously going to be longer than 26, so it's not going to fit in the bottom. So what we want to do is see whether it can fit diagonally like that. Okay, so if it's 30 centimeters, it should be able to, we're going to see whether it can fit in like that. So what we really need to do is find out the length of the hypotenuse of this right angle triangle. So I'm going to draw the triangle again. So remember, we're working with Pythagoras' theorem, we're working with right angle triangles. So I've got a right angle there, there's my triangle, this side down here is 26. And this side across here, all right, is 18. And I'm going to put this other side here, I'll just call it P, okay, because we're looking at a pencil case. So I want to find the length of this side here, P. Okay, now if that length there, P, which represents this length here, if it's bigger than 30, then my pencil case should fit, my ruler should fit into the pencil case. So let's start using Pythagoras' theorem. Our longest side is P, so you really should draw a circle around the P. I'm just going to put a circle around the longest side P. And remember, we're trying to work out what P is, so we're going to do P squared equals 26 squared plus 18 squared. So we've got, again, P squared equals 26 squared plus 18 squared. Now the 26 squared and 18 squared are on the same side. We can just work that out. We can do it all in one step on the calculator, and we get P squared is 1,000. Remembering we're just trying to find P, not P squared. So P is the square root of 1,000. So you do that on your calculator and we get P is 31.6. So this length here, that's actually 31.6. So if I put a 30 centimeter ruler in, that's shorter than that. It should fit in my pencil case. So we can write a little conclusion up. So we can say, yes, the pencil will fit. Sorry, not the pencil, it's actually a ruler. So we can say, yes, the ruler will fit because the longest ruler that will fit is 31 centimeters long, and your ruler is only 30 centimeters long. Okay, now for question 21. Now question 21 is a worded problem and there's no diagram, so we're going to have to draw a diagram for this question. Now in this question they tell us that a 4-meter ladder, so that's the actual length of the ladder. Remember, when you put a ladder on the wall, it goes at an angle to the wall. You never put the ladder straight up against the wall. So I'm just going to draw a right angle triangle here. We're going to pretend that this line down here is the wall and the line along the bottom is the ground, and this sloped line is the ladder. So that ladder is 4 meters long. So I'm going to put 4 meters on that. So the ladder is 4 meters long. It reaches up a wall, so here is my wall, and there is a window on the wall, so I'll just put up here W, the window's up there. So the window's up there. They're obviously climbing up the ladder to get into the window, and this window is 3.2 meters high. So I'm going to put that this length from the ground up to the window is 3.2 meters high. We have to find how far from the bottom of the ladder is the bottom of the wall. So if this is the ladder, where I'm pointing here is the bottom of the ladder, and if this is the wall, where I'm pointing down there is the bottom of the wall. So I'm just going to put a right angle triangle here because the wall is built straight up and the ground is straight across. So I want to work out this distance D down here, the distance from the bottom of the ladder to the bottom of the wall. So I'm going to first start off by circling the longest side, which is the hypotenuse. So the hypotenuse is the 4. Okay? So remember, the two shorter sides squared add up to the longest side squared. So remember, we're trying to find D, so we write that first. So we go D squared plus 3.2 squared equals 4 squared. So we can just write that out. Remember, just the M is just the units, meaning meters. So we've got D squared plus 3.2 squared is 4 squared. Now we need to work out the 3.2 squared and the 4 squared. So we work those out. We get D squared plus 10.24 is 16. And we're trying to work out D on its own, or D squared. So we need to move this plus 10.24 over to the other side, and it becomes D squared is 16 minus 10.24. We work out 16 minus 10.24 on our calculator, and we get 5.76. Now that's what D squared is. It's not what D is. So you need to do D is the square root of 5.76. You work that out on your calculator and you get that D, this distance here, is 2.4 meters. So therefore, the bottom of the ladder is 2.4 meters away from the wall. Okay, for question 22, we're told from home, Saleh walks 1.2 kilometers north. So Saleh will start down here and walk up north for 1.2 kilometers. So I'll just write that in first. Then Saleh turns and walks 0.9 kilometers west. Now if that's walking up north, west is this way. So Saleh turns and walks west over here for 0.9 kilometers. So I'm going to put a little right angle in there as well, and I'll put that distance there, 0.9 kilometers. And then we're asked how far is he directly from home. So I'm going to put Saleh ends up there. So Saleh starts here, goes up north, turns west, ends up there. We want to work out this distance here from home. So remember, D is the hypotenuse. So we've got D squared equals 0.9 squared plus 1.2 squared. So we'll just start off with that. And then we can start to work it out. So you can do 1.2 squared plus 0.9 squared on your calculator, and you'll get 2.25. So remember, we're trying to work out D. So D, that's what D squared is 2.25. So D will be the square root of 2.25. And when you work that out on your calculator, you'll end up with D is 1.5 kilometers. So Saleh started here, he went north, and then he went west, ended up there. The distance he now is from home, this distance here, the hypotenuse, is 1.5 kilometers. And just notice in this question that the hypotenuse, 1.5 kilometers, is longer than the other two shorter sides. And hypotenuse is always longer than the two shorter sides.